So finding slope of a line from a graph in 2 points. This is a good lesson because it's so fun. We're going to draw some rainbows. Anyways, sloppage is a huge deal. If you struggle to understand some sloppage, then your grade will be very sloppy. So this will be in a lesson, and if you guys don't understand, you need to get to math lab, all right? Because not only will you use it all throughout 8th grade, but also all throughout 9th grade, 10th grade, 11th grade, and 12th grade. And then if you want to go to college, you'll still need this lesson. Okay? So for those of you that forget this lesson, get some help! All right, here we go. You are special. All right. In the previous section, you saw that a constant rate of change is an attribute of a linear relationship. If you don't remember that, that's the truth. Okay. When a linear relationship is graphed on a line, you call the constant rate of change of the line the sloppage of the line. If I remember, I often referred to it as like the angle, right? Yeah. Which is what this really is, but if we can refer to it as a slope, it will lead into the angle stuff in a different grade. So, this box radical, you'll have to memorize it because it will be on the test, except for they're just going to take, like a word away radical.
Can we turn off the lights?
Maybe round up and count. Oh, it's all on your paper. Right? Maybe they'll take some words away like these. But then you got to fill them in. But, of course, we need those words right now. Here is what the box says. The sloppage of a line describes how steep it be. It describes the change in y values compared to the change in the x values.
Do we need to learn that and word for word?
Word for word. Well, here's the nice thing, though, is if you forget the general concept of this idea right now, there's a poster for it. And the poster,
where?
It's right there. You just follow. We're getting there. We're almost there. All right. Oh, bam! See where it says sloppage? I found it. There it is. Not only does it say sloppage, but it tells you all the other things that it means, which we'll go over today. All right. So the following investigation will examine how sloppage is measured. On a properly built staircases, all of the stairs have the same measurements. Because it'd be weird to be walking up a set of stairs, like unless you wanted to really, prank someone. If they just changed weird, it would be weird, right? Like one steps is all nice and fancy, the next one different. Yeah, it'll throw you off, right? Plus the government doesn't allow you to build houses like that, so whatever.
What if you did one of those piano tile things, or like when people put little sound tiles when you'd step on it, like make the sound of a piano, and it'd like go up the scale for as high you went?
I have absolutely no idea what you're talking about.
Okay, so never mind.
All right. What?
There's a video I saw.
He's talking about there's stairs, but they are like keys on a piano. So when you step on one of the pressure plates or whatever, one of the stairs, there's a huge sound system right next to your ear that blasts the sound.
It's not like
Awful when there's lots of people on the stairway. Dun dun dun
Oh.
dun dun dun.
I'm kind of worried this is leading into like a fat joke, like, hey, Mr. Sal, when he steps on the ground, it makes a loud sound. Because he's so fat, right? Okay, well, I don't know what the heck is going on. Like, there's some blasting sounds when you take a step on the stair. I've never done that with any stairs before. Well, if it was Linden instead of London, maybe I could go there. But do they exist in London? Is that true?
Yeah.
Oh, okay. Maybe someday I will make it to London and I will step on those stairs. If they will allow me not to break them, yeah. Mm-hmm. Thanks for the fat joke again. All right. Hey. All right. The important, here we go. The important measurements on a stair are what we call the rise, which is up and down, because, does that make sense? It would be up and down rise? Okay.
Yes.
And then the run, which is horizontally, because it'd be hard to run on a riser. All right. When building a staircase, these measurements are chosen carefully to prevent the stairs from being too steep, and you get to where you need to go. Okay. One step from 3 different staircases has been given below. Here we got staircase Juan, which is a 5-inch rise. And by the way, that 5 inches is up and downwards, right? Like this. And then we got a 5-inch run like these. Yeah, very
I
nice.
think that one's the one.
What about this one, which has a 3-inch rise and an 8-inch run? And then staircase 3 has a 6-inch rise and a 4-inch run like these. Again, the vertical measurement is the rise, the horizontal measurement is the run. State the rise and run for the staircase. So staircase 1, what'd you get? 5, and the run? 5. You could label these in inches if you want, that'd be nice. What about staircase 2, rise? 3-inch. Run? 8-inch. Staircase 3, rise? 6-inch. Run? 4-inch. There we go. So before we get into the graphing these, which of these is the steepest of all of the staircases?
3.
3 is the steepest?
Yeah.
Why?
But
Why
also
is
the
it?
shortest.
Is
By the
okay.
run
Why would
twice.
short be more steep though? That's the thing.
Well,
It's like the run is the shortest, but then it.
does everyone agree that it's a staircase 3 then?
It doesn't care.
Yeah.
It doesn't.
Yeah.
Well, it happens
Yeah.
to be the snatch, yeah.
So you're saying that
Is it like the biggest one?
if you were to make a staircase with staircase 3, the stair 3, then it would be the steepestest.
Yeah. It's like the Lord of the Rings.
But no, it does matter where you do it.
Yeah.
It does matter how big the run
Like
is,
old
because
houses.
without the run, it could
Like,
be
yeah, some old houses are like that, yeah.
Because even if you have like a 6-inch stair, you could have like a 12-inch run, so then it wouldn't be very steep.
That's very good. So
Steep is like.
technically it has nothing to do with how high it goes.
And you would be going.
It depends on how high and how far it goes. So in other words, the rise and the run have to be related in such a way that it will make it steep. So let's go down in here into the graph. Well, staircase 1 I will do in red. So we're going to start at 0. That will be a good way to tell each of these. This one goes up 5, and then to the right 5, right here.
Oh, it's a staircase.
Now that's just one step though. Let's it says to put in the first 5 steps. So that's one step. I'm going to go up another 5, and then to the right another 5. Run 5. Rise of 5, run of 5. I got 3 steps now. Rise of 5, run of 5. 4 steps.
Also, it's like 5
Rise
times.
of 5, run of 5. That's a nice staircase right there. But we don't know what to compare it with in terms of how steep it is. That looks like a pretty good staircase though. All right, staircase 2 I will do in purple. This one is going to go up 3, which is, for me, it's right there. And then I got to go over 8, to the right 8. Bam, and we can see that is the first step, right here. But then I got to go up another 3. Trying to be very careful, it's very hard on this thing. And then over 8 again, another right 8. So looking at just the first 2 steps, which of these 2 staircases be the steepest?
The red one.
Yeah, the red one so far, but let's finish all 5 steps. Bam. Up 3 to the right 8. 5 times, 5 steps. Oh, bam! Next up will be green, staircase 3. This one says to go have a rise of 6. So I'm going up 6. Bam, to the right 4. Hopefully you guys can see that. Now let's try the next one. I'm going to go up another 6. And then to the right 4 again. Right here. It's very light, but you should be able to see it hopefully. And then up 6, another 6. and then to the right 4. So I got my 3 steps. Let's do another 2 steps. Up 6. And then to the right 4.
That's the tallest one, I was right.
And then up 6. And then to the right 4. I think I got that right. Hopefully on your papers that looks a little bit better. But so looking at these 3 staircases, which of them is the steepest?
C.
3 is. Staircase 3, or C if you want to make it C. Which staircase would you guys like in your house? 1? I like staircase 2
Hey.
because the less steepness, the less energy expended.
Actually, no, I want
Well, I know, but it goes farther, but
Well, actually,
I'm all about less work. I would break a sweat on 3, on 2. I mean 1, what the heck. Alright, this is a good activity because for sloppage will always be described in fractions. And if it's not a fraction, we will force it to be a fraction. No, the fraction's good because it shows us the rise and the run, which will allow us to make a staircase like we have done right here. Well, we already determined which of the staircases was steepest. It was staircase numero, let me get this, there we go, numero trace. Yeah. Alright, what about these ones? Let's look at number 4. So now we're looking at positivity and negativity for the sloppages. Now remember, it's rise over run, right? So here's what I recommend for all of these rise and run stuff. In terms of negative or positive, let us always go to the right. So kind of like how we would read. So on A, I'm going to start at this point right here. And see how I'm coming down the line right here? So that means to get to the end of the line, I've got to go down and then to the right. See how I've made the stair right there now? Well, if I went down, that would make my rise a negative because I went downwards. And then I went to the right, which makes my run positive. Well, in the fraction, it's rise over run, so my rise is negative, my run is positive. If I have a negative divided by a positive, my answer would be a negative. Alright, so I will always do this from left to right. If for some reason you want to do it from right to left, that's okay. You just have to be able to keep track of which direction you're going in. So if you started right here, you'd go upwards, because now your rise is positive. But your run now is to the left, which makes that negative. See, there's no difference between a negative divided by a positive compared to a positive divided by a negative. It's the same thing. So yeah, you should still get a negative sloppage on that. Plus, it's kind of like, hey, if I set my guy here at the bottom, at the top of this, farthest to the left.
Somebody's calling you.
See how it's kind of like a hill is going to slide downwards, which is why it'd be negative. So if we look at B, once again, I'm going to start on my left, going to the right. So my rise is going upwards. So that's a positive over to the right, which is also in the positive direction. It's a positive divided by a positive, which is, that makes this sloppage positive. Alright, C. On these, this one I'm going to start from the leftist most point going to the rightest most. So again, I'm going to go upwards and then to the right. So upwards is positive, to the right is positive, which means I got a positive divided by a positive, which will produce an answer, a sloppage that is positive.
So it goes up and right, positive. So if it goes to the right.
That's a good question. So let's say that on D, there was no axis here. That wouldn't matter. It doesn't matter where it is on the graph or in terms of the quadrants. All that matters is direction. So on D, when we do these, right, I have this point right here, going to this point right here. D, this one's going to go down just a tiny bit, so that's a negative. Going to the right, bam, positive. So a negative divided by a positive will produce, this will produce a negative sloppage.
But you have to be
Yes.
careful because the other way, way, like if you go this way, then it's going up. On
Yeah. That's why we always go from left to right. That's what I showed on A radical. See, if I stand here at the farthest most left point, let's do it on B. So if this was me, yeah, I'm fat, okay. So if I'm standing at the bottom, now I've got to go upwards, which makes it a positive sloppage. Because I'm moving on up. That's a positive beam.
From left to right, if the line's going up, you can be pretty sure it's
Yeah, but you have to go from left to right.
Yeah.
Yeah.
So
We will talk about that. It's a good question.
would you rather have this Excel?
See, now if I was on C, I would probably just not go anywhere because it's too steep. But if I were, I would have to climb this horrible thing upwards, which makes the sloppage positive. D, on the other hand, bam. I can just sit down and roll downwards.
They're fun to
See?
repel, though.
There we go. So that makes that one a
I would
negative.
actually.
Explain how you know whether a line of a graph has a positive or negative sloppage. Okay. Well, if the rise is, if it's going, oh dang it. It's going to take a lot of writing. All right. All right, so what we did right there with the drawing the steps, it's a right triangle is what it comes out to, and that's what this next part is doing. For each line graph below, draw a right triangle to calculate the sloppage of the line. So to figure out the sloppage, we got to just find 2 points that we know the actual values of those points, the ordered pairs. So this graph, let's look at 5. 5,
What's a right triangle?
I'll show you. So a right triangle is going to have one angle that's a right angle, which means it's 90 degrees. Well, we'll see it, okay? So I can see that this line goes through this point, which would be -5, 0. And we'll look at the points later, but it also goes through this point, which is 0, -2. And it also goes through this point, which is 5, -4. All right, from radical, let's draw a right triangle. We're going to use 2 of these points, and we get to choose which 2 we want to use. Do you guys want to use -5, 0, 0, -2, or 5, -4? Which 2? Yeah, both of them, Just 2 of them, though. Just the last 2, okay.
The number on.
All right, so I'm going to use this one and this one. See how we made a right triangle with this right angle radical. Now I've got a right triangle. This will help us to figure out the rise and the run. So, on at these, my rise, again, I'm going to start from the farthest left point. I went downwards 1, 2, 3, 4. I went down 4. So right now my rise is a -4. And then my run is starting radical, going to the right, so that's a positive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Now this is -4/10. We should simplify this because we can. So, yes, that would end up being, if we were to simplify these, we're going to divide 4 by, -4 by 2, and 10 will divide by 2 as well, giving us a -2/5. So this is the actual sloppage. If we had used this point radical, then we would have went down 2 into the right 5. No need to simplify. All right, what about number 6? All right, number 6. Again, we got this point radical, which would be -5, and then -4. That's that point. It looks like it also has a point at this one, 0, -2 again. And then we got a point radical at 5, 0. So again, we only need to use 2 of these points to make a stair step. We only need 1 stair step, but you can have 2 if you want. Let's do the middle one then. All right, so from this point farthest to the left, I'll use purple. I'm going to go to this point right here in the middle, so I'm going to go up 2. So that's a +2. My rise then is a +2. And I'm going to divide this by the run, which I will go to the right here. So there's my right angle, my right triangle, which is a stair step. And I start from right here. I'm going to go to the right. 1, 2, 3, 4, 5. The right is in the positive direction. I went 5 units. So that's my denominator 5. So my fraction for the sloppage is 2/5. So that's a really good question. It doesn't matter which 2 points we use because it's a constant rate of change. It's not a changing rate of change. And that's what the poster says is kind of saying right there. So rate of change, but it's constant, always constant, okay? All right, let's look at these. So let's find 2 points on these. I'm going to use this one. It doesn't matter which 2 you use though, right? This one right account is a -8 and then -5. And then let's use this point right account, which is at -8 and a +5. Well, between these 2 points, what is my rise? Well, from here I would start, I'm just going to start at the bottom and go upwards. That way it'd be nice positive. How far up? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My rise is a +10 because I went upwards 10. Well, how far is my run? Well, let's count. 0. Because it doesn't go to the right or the left, right? So if I were to simplify this, 10 divided by 0,
0.
oh yeah, we want to say 0, but it's actually infinity, which is undefined. Because how many times does 0 go into 10? An infinite number of times. So this one is just an undefined sloppage.
So like every straight line,
why did you
could
simplify
you just
it
write
down to
undefined?
I didn't really simplify it. What I did is I did 10 divided by 0. Well, how many times does 0 go into 1? Infinite, which is an undefined value. All right, number 8, this one gave us 2 points. That was very kind of them. Okay, well, let's start at this point right account. And again, we're going to the right, right? So this one, this value is, it looks like it's a -3x value. 1, 2, 3, 4, 5. So a -5 y value. And then over here, what is that? 1, 2, 3, 5 and -5. Like at these. Well, how far upwards am I going to go? What's my rise? Yeah, 0. And then how far to the right? I go
8.
8, thank you. Well, what's 0 divided by 8? 0.
Oh, that's
This one is 0, right?
tricky.
How many times does 8 go into 0? 0. Oh, did I say that right? 0 go into 8.
So
Yeah, that's better. That's better. All right, number 9er. Graph the following pairs of points. Use the graph to determine the sloppage. So we'll use those right angles, the right triangles, the stair steps. All right, so let's graph these points. I got 4 and 3, which would put me right account. And then I got 0, 1, which, oh, that was a little off. Yeah, right there. Right? So if I created a line connecting at these, it's not perfect, but it'll work. All right. So for these, again, we'll make our right angle. So, or triangle, whatever you want to call it. Stair step. That works too. Well, from right here, I went, I'm going from left to right, so I went upwards 2. So in my sloppage, M, which is shown on the poster, my sloppage is upwards 2, so that's a +2. And then I went to the right, how far? 4. So I got 2 over 4, so I went to the right, so that's a +4 as well. If I simplify these, we'd divide both these by 2, right? And we'd get 1/2. Very good. Now we can see that it's 1/2 as well if we just went up 1 to the right 2, up 1 to the right 2. See how it hits that point right there, 2, 2. 2, 2. All right, what about 10? Let's go ahead and graph at these.
Okay, please do this.
So 1 4, and then -2, 6. Right here. Let's make that, let's graph these. Oh, that's pretty good. All right, good luck.
Haha!
Why are we doing 6 cents today?
Because today is Thursday.
So,
And the people who found this were Irish.
You go this far first.
Oh, okay. We're doing it
Okay,
that way.
what?
So let me make that smaller for you. That's better.
Okay, there. So then you go positive 3. You go to the right, positive 3. Then you go down. Negative 2. Sorry, let me catch up there. Negative 2. So then you do 3 divided. No, that seems wrong to me.
It's because you went right to left instead of left to
Right,
right.
sorry.
So it's going to be, yeah.
So then you go negative 2 over 3. And that doesn't simplify down.
That is correct. Excellent work.
This?
So be careful because I always recommend doing the rise first.
So we don't get
He did the run first, okay, and he almost put it in the numerator, but the run doesn't go in the numerator, it goes in the denominator, which was caught and was corrected. That's very good. Here's number 11. We'll do this one together. Well, this one doesn't have the graph, so it may be a little bit difficult to count, but I can still draw my right triangle, my stair step. So I can see I went from A, which has a y value of 1, up to 3. That means I went up 2. That's my rise, which is positive 2. And then my run, I went from 1 also to 3, which would be a run of 2. And I went to the right 2, so that's positive 2, giving me a run of 2. So if I simplified my sloppage, it would be 1 over 1, however you want to do it. You can just write 1. If you wrote 1 over 1 on the test, you'd be fine. Now this one doesn't really have a look of a sloppage of 1, which should be more like these.
Yeah, it should be okay. Right.
But
It doesn't have to be.
it doesn't necessarily have to. I mean it should, but just know that these ones are kind of just there to help you understand what the heck is going on. Which means we don't really need the scale there, okay? So if the scale is different, it may look a little weird. Good luck.
So you want to do the rise first, so the triangle would look something like this. And then 4 minus 1 is 3, because the first number is always the rise, so that's 3. And then 8 minus 2 is 6, so that's 3 over 6. And if you want to simplify it, that's 1 over 2.
Okay. Thank you.
That's good, right?
Yeah, the scale is definitely maybe a little bit off, Radical. But we do need to be careful, okay? Because the upwards values, Radical, it's actually the second number that we're looking at there, right?
Oh, it is.
The rises is the whazes. So from 2 to 8, that would have been the sixer. And then the run. So it's a small thing that we can take note of on that, okay?
Wait a second.
6 over 3. So that would simplify to 2. So it was all that happened, and you guys probably noticed that right there, is that the value we got was reciprocated or inverted there, okay? 13 for someone. Good luck.
So from negative 1 to 2 would be 3. And then from positive 1 to positive 2 would be 1. Did I get that right?
What do you guys think? Thank you. Yeah, that's good. That's very good. Oh, graphing points can be time consuming. Develop a procedure for calculating sloppage without graphing each point. Explain your procedure below. Show that it works for problems 1 through 4 above. Well, I guess that's actually what Megan was talking about right there. Right? Let's take a look at these with graphs. So see how we're really just finding the distance between the y's. That's our rise. And what operation gives us distance?
Oh, that's, wait, wait, I need this.
That's a speed. You guys remember what operation gives us a distance? It's subtraction, right? So here's the thing is, we got 2 points. So we got a y value for the second point. And if we subtract the y value from the first point, then we have our riseness. Now, the runness is the difference between the x's. So if I took the second x value and subtract it, again, that will tell us the difference or the distance between the x's. But I would just have to subtract the first x value. And that's what this equation has given us right here in number 15. Right there. So the first and second values for not just the x's but the y's, it depends on which one you want it to be. So up and here, right there, let's say that b were point number 2. Well then, what's the x2 value? Well, its x value is 3. So if I were to compare this one with number 11, my x2 value is 3. And the y2 value is just the y value for the same point, which also is 3. Now we are subtracting because we're finding the distance between these. But now we got a, which we're going to say is point number 1. And its x value is 1. And its y value is 1. What's 3 minus a 1? 2. That's what we got for the rise right there. What's the run? 2. 3 minus 1 is 2. That's what we got right here. And when we simplify these, we get the 1, which was the sloppage that we found originally. On number 13, we did use addition because this would be considered like a 2 minus a negative 1, which would change that into addition, which again gives us the distance between the two values for the y's. Yep. So yeah, if we're subtracting a negative, then yeah, we will end up adding, which is important to know. All right, you guys want to try it on number 12, right? Or 13, which one do you guys want to do?
Wait, what?
We'll do the same thing, but we'll use this equation stuff. 12? All right, let's try it on 12. Which point do you guys want to be number 1? D or C? D. D is number 1. So my x1 value, right here, is 4. And my x1 value goes right here in the fraction. And then its y value is 8. So my y1 value is 8. So that means that C is the number 2 values. And its x value is a 1, which goes right here. And its y value is 2, which goes right here. Okay. So what's 2 minus 8? Negative 6. 1 minus 4? Negative 3. So if I simplified these, I would end up with 2, which is what we got right here. Stair steps are good. The equation's good. Use whichever one you like the mostest. Discuss and compare your method for calculating sloppage without using right triangles on a graph with a partner. Now discuss this formula. What does it mean? How does it work? We just went over that, so we're good. You guys go through these and find the sloppage. That triangle Y and the triangle X stuff, that's changing Y, changing X. It's just asking for the sloppage. That's all. Oh yeah, by the way, 16 is done for you. So, you know. By the way, it's showing that it's using this equation stuff right here. But if you don't want to use the equation stuff and you'd rather graph it, then do that, okay? All right, let's do it. Let's have a smaller pen right here. There we go. All right, the first point I got, -3, -6, so -3, -6, right here. And the next point is 6, 0, so 3, 6. Oh, that's the wrong place. There we go, 3, 6, right here. That's better. So between these points, and we don't really even need to draw the line if we don't want to. If we can just use the triangle like these. So it looks like I'm going to go up 6, which is my rise, up 6. And then I'm going to go to the right 9er, which is in the positive direction, so 6/9. And if I were to reduce this, I would get 2/3. Alright, again, the equation would work the same way if we made this point 2 and this point number 1. So then I've got my y value is 0, the x value is 6, minus the y value is -6, and the x value was a -3. And that's nice because these both change to plus anyways. So that becomes the 6/9, which became the 2/3. Alright, what about number 18? 4, -3, 1, 2, 3, 4, -3, -5, 1, 2, oh, it's not going to show it on the graph. 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. I mean, it'd be up here, but it's off the graph. So let's use the equation instead. I'm going to say this is point 1, this is point 2. We got subtraction. And for the y2, I've got 9er. For the x2, I got -5, because I'm using this point. And then we got my number 1 values. My y value is -3, and the x value is 4. Again, I'm using this point. So to calculate at these, I'm going to change that to plus 9 plus 3. Bam, I get 12 over 5 minus, -5 minus 4, which is -9er. Both of these are divisible by 3. So this would simplify to 4 over -3.
So, Mr. Sal,
In the previous section, you saw that a constant rate of change is an attribute of a linear relationship. When a linear relationship is graphed on a line, you call the constant rate of change of the line the sloppage of the line. So, sloppage. In the box right here, you'll have to memorize this thing word for word for the test, unless you don't want full credit, then it'd be fine not to memorize any of it.
Wait, do we have to show our
So-
work on it when we do it?
Yes, because if you don't show the work, then you won't get the credit.
Why?
Because that's how it works, man. So, you know, they may show some missing stuff up in here, like this. And then you got to fill in the blanks. You just go in there and fill them in. There we go.
The
Pretty good.
slope of a line.
So, the slope of a line describes how steep it be. It describes the change in y values compared to the change in the x values. There's a poster for all the sloppage stuff that you could ever need. It's over here. If you just follow the light right there. It's going to be over here.
It's all sloppy.
You can see it right there. There it is. Sloppage. So if you forget, that's a sloppage. Well, sloppage is a rate of change. The O change thing comes from Ireland, right? If you guys have Irish heritage, there's probably some O changes in your family tree.
It looks like radio.
You're reading it wrong. It's rate o' change, okay? Back in the medieval times when everything was evil, then the Irish discovered this rate of change, and well, they named it after one of their kids, Rate. And so they called it rate o' change. Which is pretty cool if you think about it, right? Well, yeah, in America we don't say o' change because, you know, we hate foreigners. So we call it the rate of change here. You see the changes? All the changes. Whatever. And so if you ever need some help and forget all this stuff, I mean, it doesn't say that word for word, but it's up there, okay?
I don't get the rise and the run.
You will. Hopefully. The following investigation will examine how sloppage is measured on properly built staircases of all of the stairs have the same measurements. Because it'd be really weird if you were walking up some steps and then they just changed them suddenly, right? Which would be a great joke. Like Harry Potter. I don't know what that means, but I assume...
It's like move, and then some of them like don't have stairs. There's like fake stairs and stuff.
I don't know what that means. I know Harry Potter was about that dude with the ring, right? And then he walks up the mountain, and then he has to cast it into the fire. I was close.
Harry Potter has to kill.
Harry Potter's the one with the, yeah, he's got the scar, and then you got the werewolves, and the vampires come, and they have to fight each other, right?
No, that's Twilight.
Oh.
No, Harry Potter's the one about the girl that loses her shoe, and then there's a prince that comes after Harry Potter.
Oh, I never saw that one. Actually, I never saw the vampire one, but I don't know the difference.
He's also got those
Yeah, so if you guys understand that example, think about Harry Potter. It'd be weird for, well, that's why it is weird, because then with, you know, they change the steps while you're trying to walk up them.
It's called magic.
Like
It's
magic.
like magically changed.
Yeah, but this would be a case where you're purposefully doing it in a house to a family and ruining their lives, okay?
Or you do it so it's just
Hogwarts
barely
does it
taller than them
first,
so they can't reach up.
Yeah, but that's to help them with magic? I don't know. All right. I'm going to keep reading this, by the way. The important measurements on a stair are what we call the rise and the run, which is great because it's very catchy, rise and the run. When building a staircase, these measurements are chosen carefully to prevent the stairs from being too steep. Because, you know, you don't want to build a house for a fat person like me and then have stairs in it, which are too steep. It'd be hard to climb them all the time, right?
You need one of those like lifty things that you can sit down.
Like an up.
I like it.
You know,
I
that's
like
like
it.
an up.
I don't think they carry people with my weight, so it may have to be like one of those industrial ones. And to get where you need to go.
A whole thing. Just like a whole thing covers the whole staircase and you just ride up.
I mean like Pee Wee Herman where you get on the pole and then you just kind of go down the pole.
Fireman's bowl.
Like a fireman, yeah. That's good. An escalator. All of those are very affordable options as well. All right. Well, this is why I don't have stairs in my house anyways. One step from 3 different staircases have been shown below. Staircase 1 right here has 5 and 5. Let's take a look at this one right here. 5 inches rise, which would be these right here. There's a 5-inch rise and a 5-inch run.
So you like ride.
This is a horrible step unless you have tiny feet.
Wait, why?
Because 5 inches is very small.
Because it's like this big.
Oh, 6'4" would be the best one.
All right. But
They're all awesome.
that's okay. In part A, what is the rise on this thing? Well, we've shown them we're a 5. And then the run is a 5-inch run as well. So we'll label these 5 inches each. Staircase 2 right here.
That's a bad staircase.
We got a rise of 3-inch. Because that's our up and downer.
That's a bad staircase.
Rise is always up and downer. And then the run is 8-inch right here. So there's our 8-inch run right here. This one could be a winner. It all depends on your preference.
How he runs.
Here we got a rise, which is the up and downness of the step at 6-inch. And then the run right here is at 4-inch.
Okay, wait, are they all gonna?
All right, so there's our steppage, our staircase steps, whatever you want to call them. But which of these do you guys think would be the most of the steepest of them all?
The third
6'4"?
one. Third one.
Is that how tall you are? How tall are you?
I'm not 6 inches tall.
I just
All right.
How tall are you with the hair?
Are you 6 foot?
Let me finish the step problem here first, okay? Well,
No, you can't finish it.
Um,
That's how tall you are.
Who thinks that staircase number 1 are the steepest? No one. Staircase 2? 3. Alright, who will tell us why? Why staircase 3? What would make it so steep? Porter.
I'm guessing the run of it isn't the shortest.
Alright.
No.
There, we need to add to that. There's some, you're right, we just need to add a little bit to it. Camilla?
Yeah.
Yeah.
I think it's because the rise is like longer than the run.
That would work. The rise are longer than the run, which is not true for any of the other 2 steps. Okay, so that is what will make it the most steepest. For example, if I had another step up in here, let's say it was something like these. Well, if this were 12-inch right here, and this were, I don't know, 14-inch. See, inches, right? 12 inches is much bigger than 6, 3, or 5, but since it has a run of 14, that will make it not as steep. Just keep that in mind, okay? All right, onward to number 2 with the graph. This one's the best part. Using the rise and run for each step, graph the height a person will be after each step for the first 5 steps. I'm just going to graph the first 5 steps is what I'm going to do there, okay? Do this for each staircase. That's better. All right, so I'm going to start with staircase 1, which I will do in red on the graph. So this will represent staircase 1. So I'm going to start at 0. I got it. We're good. Okay. All right, so I'm going to start there at 0. I'm going to go up 5. Because that's my rise, and then my run is 5 as well. Bam, there's my first step. So that would take me to this next point right here. Well, that's just 1 step. I need 5 steps. There's 2 steps. Up 5 to the right 5. Bam, and I'm starting a staircase, building it for this family who will use it. Unless their dog falls down the stairs, that'd be bad. But if it's a Tongan family, they could eat it, right? All right, so up. No, that's for reals, man. They'll eat the
I
dog.
went to Honduras and I
Bam. Was it good?
No.
Whoa, you went far.
It wasn't really quite chicken,
But it was good.
it was okay.
It was great. All right. That's good to know. That's good to know. All right, that's okay. They're just.
How far up do we do it? All the way?
No, I just put 5 steps on there. That's all I did. Now I'm going to do staircase 2 in Poiple. This one I'm going to go up 3. And then I'm going to go to the right 8 right here. That's just 1 step though. Again, we need 5 steps. So I got to go up 3. And then to the right 8. Then I'm going to go up 3 again. And to the right 8. That's 3 steps so far. 1 more step will be 4. Up 3 to the right 8. And then finally up 3 and to the right 8. So looking at this graphage, which of the 2 staircases are the steepest that we've graphed?
5.
Yeah, the 5, 5 staircase 1 in red, steepestness of them all. Okay, now we're going to do staircase 3 in green. All right, C, I'm going to go up 6 and then to the right foe. I think I went up too high on that.
See that? I can't even see it. I drew it.
It's right there. Bam, nailed it. Then I'm going to go up another 6 and then to the right FOMO right here. And then once again I'm going to go up 6 and to the right Fjord. And now I'm on my,
6 feet and
that's
4
3 steps so far.
or 4.
Now I got to go up 6 and then to the right foe. And then finally up 6 mo and to the right FOMO. So there are our 3 staircases, and it appears that staircase 3 are the steepest. So if you guys were going to put these in your house, which one would you put in there?
Staircase 1.
Staircase 1 for some of you guys. Got those tiny feet.
No.
Maybe you guys like a nice steep staircase, right? pull a hammy on your way up, fall down the stairs. It'd be bad. But maybe you like that stuff. I don't know. Maybe you like to kill dogs, like Olivia does. I prefer staircase number 2 because, well, I'm fat and lazy and I don't like the steep ones. Okay. So.
But if it's 3 inches, you only go up like this much.
How great is that?
It takes longer.
A lot less work.
And it goes along.
And then you
And I can lay down on those stairs if I need a rest. You see what I'm saying? All right, which staircase are the steepest? Well, we already discovered it was staircase 3.
What was that? What's that? That's a back.
No, it's a 3, right?
3.
It was like one of those ones you see on scoreboards. All right, let us justify.
Pretend that you wrote in invisible ink.
Yes, that's what this will pretend. We'll pretend. Okay. So why is it the steepest? And we already went over that, right? Because the rise are biggest from the run, or in comparison of the run to the run, whatever. Here's this next one. Do the graphs below have positive or negative sloppage? And how does we know? Well, let's look at A. When finding sloppage, especially on a graph, it's always important to start.
in the negative quadrant.
No, that is not really important for us. The quadrants are not really what we're looking at. What we're looking at is where we start, and we always start to the left, and like we read to the right. Unless, one of those Asian countries where they read from right to left, which is okay, just it may mix you up a little bit, okay? In any case,
Novels in the library, and like some Asian person wrote them, and they're like.
isn't that great?
That's
Those are awesome.
Japanese.
Well, I think Chinese do as well.
I think Koreans.
Koreans, yeah, I think Koreans do.
Arabians also right.
Arabians, that's correct. They do from right to left as well.
I love Guatemalan.
All right. All right, here we go. So here's what I'm going to do is I'm going to make a little triangle out of these. And since I'm going to the right, I'll always go to the right.
That's easy.
Now I want to find my rise first, and this will be a fraction.
Oh, so wherever the triangle points, that's if it's positive or negative.
Kind of. Here's what it is. So see how I went from this point? I went downward. Well, downward is in the negative direction. That's my rise. My rise went more downward rise, which makes that a negative.
How would you know which way to draw your triangle?
It won't matter. And I'll show you why here in a moment, okay? Now, from there, I had to go to the right, which is in the positive direction. That's my run. My run is positive. Well, if I have a negative divided by a positive, my answer will always be negative. All right, good. Let me explain. So we start with the point farthest to the left. Now, in this triangle, I go downward, which is in the negative direction. See, that makes my rise negative.
Oh, I get it.
And then I went to the right, which makes my run positive, because to the right is in the positive direction.
But
Okay?
it's going downward.
I don't get it.
And does it go back up to the positive? So
Oh.
it's down in
Now be careful with that.
Since it's starting up here and going down here, that makes it negative, and then if it was going like this, and then it went up.
Yeah, in a way. Just be careful with that, okay? So here's what else I will say about these. Is let's say you always start on the left side, right? So let's say this was you. And well, see how you're going down the hill? So it's in the negative down. You're going down to the negatives, okay? So that would make it negative as well.
Going up the hill, would it be
Well, that's B, right? B, now if you're up in here, I mean if this would be me, right? So now I gotta I mean tell me if I lied. Huh?
trying to do it like an A.
Yeah, thanks. Well, anyways, see how I've got to go up the hill? I mean, I'll never make it. That's positive. So I've got to go up the hill. I've got to climb the hill. But on the other hand, if you start right here, going to the right, up in here, see, we're going to go upwards, which is in the positive direction. That's a positive divided by my run, which is to the right.
What if you decide
which is positive.
What if you decided to draw your triangle the other way?
Yeah, that's what I thought.
Yeah, let me show you then, okay?
Which way to do it.
What is this?
Now, it doesn't matter, but I will only do it in this class after this example, always. I will do it to the right, okay? Because if we keep it to the right, it will always keep our denominator
How is
positive. Because that's the way we read as well. What was that?
How is drawing a triangle?
So,
What if you flip it upside down? Drawing your triangle right.
Yeah,
How
to
do
the-
you draw your triangle right by going up?
okay, I'll show you. All right. So again, I'm going to start with to the left. Is that okay? Now, if I drew my triangle right here, all that means is you did the run first. Well, my run is.
Always do the rise first, and you get it right.
I would always do the rise first because that's your numerator. That's your numerator value. This one, though, if you do it this way, no, there's a positive run, which is now our denominator, which is
How'd you get that
positive. How do I know it's positive? Because I'm going to the right. Now, to the right is in the positive direction. Now, if I go upwards, that also is in the positive direction for the rise. And my answer is still a positive up in here.
So if it's
Direction.
So if it's going down, so if it's going up, then it's a positive.
That's correct.
And if it's going down, it's a negative.
That is correct. All right, so see, this one would be considered positive. There we go.
That's way easy.
And what about D right here?
Positive. That's a negative. That's a positive.
Well, this one, right, we start up in here, we end down here,
That's a negative.
so we went downwards in the negative direction.
You always go left.
Yeah. All right. Be careful with this, though, because I'm not really so concerned on if it's positive or negative, as much as you understand which direction we're going when we're finding values. That will be more important. Yeah, so let's look a little bit closer at C. So we can see I got to go upwards. Oh, what the heck happened here? I'm gonna go up, and then I'm gonna have to go to the right. So up is in the positive direction. The right is positive.
Oh, so you don't ever do diagonal lines like I did? Because I drew a dragon.
No, it's more about this right triangle kind of thing like that. Yeah. Good. All right, E. Explain how you know whether a line of a graph has a positive or negative sloppage. So going from left to right, if you are going upwards, it is positive. If you are going downwards, it is negative. All right, for 5 and 6, draw a right triangle to calculate the sloppage. Label each triangle with the ratio and simplify the ratio. M equals rise over run. That is what we will do. All right. Yeah, this is okay. Oh, we can't see pink though. All right. So, when we're finding the rise and run on this thing, it was nice of them because we didn't actually have values. Now we got to find the values, and we got to keep in mind the direction. All right, so we need to identify some points that we can actually identify their values, like at these. This one would be -5, 0. Another one I see is right here, which would be 0, -2. And then I also see this point right here, which is 5,
When you do it 0, -2, it could be 0.
-4. All right, now that we have these 3 points, we need to identify 2 of them that we want to work with, but only 2. So which 2 do you guys want to work with? -5, 0, 0, -2, or 5, -4?
0, 5, 5, 4. Yeah.
All right. So I heard at these, and then at these, right here. So I'll get rid of that so it doesn't confuse us. But I want to keep that point there to demonstrate something later, okay? So if I wanted to make my right triangle up in here, I would have this line right here connected with this line right here. And that right there is a right triangle because I can put a right angle right there. And that's pretty. But I got to find my rise, and we'll divide it by the run, and I should have some kind of fraction. Well, from this point, because we're always going from left to right, am I going up or downward? Down, which makes that negative. How far down? 1, 2, 3, 4. So I did go down 4. That's going to be my rise. down 4, or negative 4. Well, from there, from this point,
It's 9. Positive 9.
I've got to go to the right, which is in the positive direction.
9.
How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
There's 2 5s.
10.
So let you know your mic is cutting out.
Oh, well, not on here. We're good. All right. Well, this can be simplified, right? So negative 4, both these are even, so I can at least divide them by 2.
-2, -2.
Well, what's negative 4 divided by 2?
-2.
Negative 2. 10 divided by 2?
5.
5er. There it is. That can't be simplified anymore, and we're done with that one. Here's something else some of you may have noticed. Well, if we used this other 2 points and made this right triangle right here, that would have given us the simplified form. All right, let's do these. Okay, so we got a few points again. We got this one, which is at negative 5, negative 4. Then we got this point at 0, negative 2.
We should do it with the 0, negative 2.
All right, we can. And then we got 5, 0, right? Well, you guys want to use these two closest to each other then. These two over count. That's good. We can use these two. Let's zoom in then. Now keep in mind it shouldn't matter if what points you used. You should still get the same answer, which is why it's called a constant rate of change. We'll go over it. All right. For example, I got my right triangle right up in here, right along the x-side. Okay. So my rise from right here, I'm going to go up 1, 2.
Does your rise always go on the top?
That's a rise. Yeah, rise will always be on the numerator,
Oh, so you could have just cut in half.
which is what I did. I did that right here, yeah. Now from right here, I'm going to go to the right to that point. 1, 2, 3, 4, 5.
Oh yeah, I got it right.
So I went to the right 5. That's a positive 5. Let's simplify this. Done. Number 7. Calculate the sloppage of these. And this is going into what Emily was talking about up in here. So I'm going to choose this point right here. Again, it doesn't matter which 2 you choose, but I'm going to choose these 2. So let's see. If I look at my rise for these.
So you can just choose some random points in the middle.
Yeah, as long as you know what the values of those points are, yeah.
Oh, really?
Oh.
Yeah. So you didn't, like the first one that we did before, we chose the 2 points farthest from each other, but we could have chosen 2 closer. Like we did on the second
We
one.
could have done that one and that one, so this is like.
No. So we have to know because we don't know the values of those points, but we do know the value of that point.
Well, we can figure out the values of those points.
We could, but we haven't learned that yet. All right. So
How do we know we can do the values?
So on this point that I've labeled, I haven't labeled, but I'm going to. It's a negative 8, 0. I know the value of that. Okay. This other point right here is still negative 8, but now it's up 5 for the y value. I got those values. It's very clear what those values are. There's other points on there, though, that we could have used. This one, any one of these. There's 20 different points we could have used on this line. That would have been great, but that's a lot of work. So I'm just going to use 2 of them. Well,
I know that this.
all right, so from this points, I'm going to go upwards 5.
Because you use.
All right, so my rise on this one is a positive 5. What's my run?
8.
0.
So it's just 5?
So it'll just be 0 on the bottom?
All right, so this is where it gets tricky because now we got 5 divided by 0. Some people say 5, some people say 0. Both are incorrect. Let's do it.
No answer.
5 divided by 0. How many times is 0 going to 5? Infinite.
Infinite.
Therefore, the sloppage for this one is undefined.
So basically every line would just say undefined.
For vertical lines like this one, yes, because there is no run. That's correct. In this case, it's hard to go from left to right, so I just chose to go from downwards to upwards.
You could go from upwards and downwards.
But you could go from upwards to downwards, because if I make this a negative 5, it's still undefined. Always vertical lines will have an undefined sloppage. Anyways, for this one, I am going to go left to right, and they did identify 2 points for us to use, which was extremely generous. Well, I can see I'm going to go to the right. How far? 1, 2, 3, 4, 5, 6, 7, 8 is my, that's not, my run is 8.
How do you know whether it would be a positive or negative 8?
It wouldn't matter, and I'll show you why. Okay. Now, I went to the right, which makes this a positive 8. Now, what's my rise? 0. What's 0 divided by 8?
It's 0.
8. No, it's 0. Come on. The heck.
I knew it.
Well, let's change this and say we went to the left 8. What does that change about our problem? Now it's a negative 0. No! 0 is neither positive or negative. It's just 0. So horizontal lines like these will always produce a sloppage that is 0. Alright, number 10, we got to find the sloppage from these points. And it did tell us to graph these, so let's graph these 2 points first. I got 1, 4, which would be right here. And then I got negative 2, 6, which would be right up in here. And yes, we can make a line between these two. Make it a nice fancy line up in here. Bam, there we go. Alright. Well, from here, I'm just going to make myself a nice triangle. A right triangle like this. A stair step is really what that is. Well, from here, since I'm going to the right, to get to the value of that point, I've got to go downwards. So I'm going to go down. I'm going to go down, which is going to make that negative. My sloppage in the rise is going to be negative. How far down did we go? 1, 2.
A negative.
Well, then from here, I've got to go to this point, which is in the positive direction to the right. How far? 1, 2, 3. This cannot be simplified anymore. It is done. Alright, here's the nice thing about these types of problems is they did not give us a scale or a grid to work with. All they gave us was the xi. In fact, we don't even need them though. Because this one was drawn wrong, I think. No, yeah, a little, oh, no, it's good. Alright, from right here, from E to F, so there's my right triangle. How far up did I go?
1, 2, 1, 3, 1.
Now remember, there's no grid on this one. We got to figure that out. We're going from negative 1 up to 2. So that means we're going to go up 3. Now the run, is everyone good on the 3 there?
Yes.
I went from negative 1 up to 2. I went up to 2. Now the run, I'm going to start at this 1 right here, and I'm going to go to the right to 2. So my run is of 1. Well, 3 divided by 1 is 3. Done.
Final measurement.
M, and it's on the poster over there, by the way. It stands for sloppage, but it's the Greek word for sloppage, which I am unable to pronounce. So I don't know what it is. Yeah, no, find someone that speaks Greek, and then you can just ask them, how do you say sloppage in Greek? It starts with M. You know, I don't know any words in Greek. I have no idea. I don't know what it is. All right, let's discuss this. We're getting a little short on time. So there's this equation for finding sloppage. M, as you can see on the poster, is sloppage. So if you wanted to, you could use this equation to find the sloppage. So let's say that they gave us a couple points. You guys give me a value. 6 and 3. That sounds good. And the other one? 4. And negative 4. That sounds great. So if I use this equation, and then I got a y2 and an x2, and then I've also got a y1 and an x1.
Why is 1 minus sign bigger than the other?
Yeah. Well, anyways, we get to choose which point we want to be the second point or the number 2 point, and which one we want to be the number 1 point. So which point do you guys want to be the number 1 point?
Have you ever cut your head?
Anyone? 6, 3. This is going to be number 1 point right now. So see the x is 6 for this number 1 point. So I'm going to go down here and replace my x1 with that value 6. What's the y value in the number 1 point? 3. It's 3. So now I've replaced those values, which means that this has to be number 2 point. Well, what's the x value in the number 2 point?
4.
4. So I'm going to replace x2 with 4. What about y2? Well, that's going to be the negative 4 value, the y value of the number 2 point. So to figure this out, what's negative 4 minus 3?
1.
Negative 7.
4.
What's 4 minus 6? Negative 2. Now I've got two negatives, which means if I were to simplify, I would make this a positive 7.5. Here's an example on the next sheet that they've done for ye. That's great. Notice they've graphed the points, and they've also solved the sloppage for ye.
How would you end up with
Huh? I beat him up, apparently. All right. I'm not going to do this. Number 22, we got these points. The first point there I'm going to say is negative 3, negative 1. That's at these. The next point is negative 1, negative 3. Bam. This point right account. So if I wanted to find a sloppage, you could use a right triangle right account. And clearly we went down 2 and then to the right 2, which gives us a sloppage of down 2 and then to the right 2. Well, if I were to simplify this, it'd just be negative 1. Well, what about 23? Give us this point, negative 1, negative 7, which would be right about here. But then it gave us some sloppage down here. And it says the sloppage is 5. I need to see this sloppage as a fraction. So I'm going to make this 5 over 1. Which means my rise is 5, so I'm going to go up 5, 3, 4, 5. And then to the right one, making a stair step, that's my next point. I can continue this pattern and find the next point. All I must do now is to connect these with a line. Bam. And now I have grafted it.
Did you write that?
The sloppage. Now I got 1 point, but I actually found 2 other ones, right? So I could put on there 0, negative 2. And I could also put on there 1, 3.
Wait, how did you find them?
So I found a sloppage, which was 5. I made it a fraction so I can see the rise and the run. I went up 5. I went up 5 right account, and then I went to the right 1. And then I did it again. Up 5 to the right 1. Bam! I nailed it.